What you see before you is a breadboard. And honestly, they are one of my favorite little aspects of electrical engineering because this, as an electrical engineer, is your blank canvas. This is where you can experiment and paint and make new things. It was really alluring to me when I first started out because things weren't permanent. And that's kind of a fear I think a lot of people have, is making a permanent mistake. With breadboards, if you do something wrong, you can always take a component out. It doesn't cost you money to change things. Of course, you do have to be careful. You can still fry things, but that's more to do with your knowledge of electronics and not necessarily breadboards. But it can help for you to know how these simple components work. So this is a breadboard here. You can see I've just got a battery hooked up to it, and we'll get into that in a little bit. But you see a bunch of holes here, and this is where components plug in. You can see that I actually have two components already plugged in here. I've got a resistor, it's 1,000 ohms, and I've got an LED. Now, all these holes, they have labels and all that stuff, and that's mainly for convenience. What you need to understand is that there's really two traces or two sets that we have going on here. We've got these power rails, and these are connected through the entire, this red rail is connected along the whole length of this board. So that means that if I put a wire here and I want to get this positive voltage out at this point up here, all I have to do is connect a wire to this hole or this hole or this hole, or really any hole along this red rail, and that'll be whatever's connected. That's what I've got at this top part actually, right? I've got my positive from my battery going into the plus, and that means it's available on this whole plus rail, right? That's what we call it, as a rail. And then you also have along this axis, we have smaller little connecting buses or little connecting rails where this guy's connected to this guy, is connected to this one, and this one. But you notice there's a really distinct clear break right here, and that means they're not connected all the way across. Only these 5 holes are connected. And this is really made to work with components like this. This is a DIP package integrated circuit. It looks like this is some sort of op amp. It's not really important. Stands for dual inline package, and what's nice is they clip in, and each one of these pins, right, each one of these pins is now connected. It has 4 connection points at least. So we don't want these pins to be connected to these pins necessarily, and so that's what this break is facilitating. Let me detail what's actually inside of this breadboard. So what's inside of this breadboard, here's one that's kind of been torn apart. You can see here's some of the long rails that I was talking about for power, and then there's these little 5-segment rails that are also available, and those are the ones that go along this way. So you can see they're just pieces of metal, right? They're pieces of metal that are have a little springiness to them, and that's what actually holds the wires that you put in. That's what holds them in place. Another thing to be aware of is that these wires here, right, these little traces that I'm talking about, they actually can't handle a ton of current. They can handle a decent amount. You can look it up online what they can handle, but it is possible, right? You don't want to do this. Put too much current in because, well, one, you can fry your component, but you can also fry and disform your board, which is something you don't want to do, right? We want to preserve our breadboards so they can live to fight another day. So what we can see here, right, is if I wanted to supply power to this resistor and LED, and check it out real quick how these are connected. So right above this little 45 here, I've got the resistor lead, and then I've got it coming across. And since it's sharing one of these little vertical rows with this LED, this guy, this pin on this resistor, and this pin on this LED are now connected. So I bring the other pin of the LED to the row right underneath of this resistor, right? It's right underneath of it. And that means that these 2 points are connected, but these two are separate because they're on different rails. Now if I want to apply power to this, right, what I need to do is I can really wire anywhere, right, as long as I've got my ground on my ground here. And I'm going to take my red wire, and once again I can put that anywhere along this rail. And I'm going to connect this to the other side of the LED. Now, anticlimactic, my LED is not lighting up. Well, it's because LEDs have polarity, so I'm going to just turn this around. And so I need to connect one lead to this positive and the other one. And there we go. My light's now on. So if you want to see, right, there we go. You can see that's totally turning on and off. Now, I could take this red wire and I could put it in multiple spots. In fact, there's 4 other options that I could connect to. Right, I could connect here, 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 or here. If I go one row over, say here, doesn't matter where I'm at, it's not connecting. So we do have to be careful, because if I did put this red on the same connection path as this black wire, I would short out my battery would get really hot. So you do want to be aware that short circuits can happen, and that if you have a power supply that detects it, it will limit its current, but my battery that's in my hand, it'll probably start getting really hot. So yes, breadboards are great because I have this ability to take a schematic and execute on a board in a way that I can go through and modify things. And it's usually your first step in prototyping.